Last time, in part 2 of our series on AI consciousness, we heard some compelling arguments suggesting that AI might one day, or even already, possess an inner life. We were left with a sense of wonder, of possibility. But now, it's time to put on our skeptical hats. What is this inner life we're talking about? At its core, it's about qualia, that subjective, what it feels like aspect of experience. The redness of red, the sweetness of sugar, the pain of a pinprick. That's the heart of the hard problem, the seemingly impossible task of explaining how physical stuff, whether it's brain cells or silicon chips, can give rise to these private, internal feelings. Imagine trying to describe the taste of chocolate to someone who's never tasted it. You can list its chemical components, its texture, its effect on the brain. You can't truly convey the experience itself. That gap between the objective and subjective is central to the argument against AI having an inner experience. It's like having a perfect blueprint of a symphony. You have all the notes, the structure, the instrumentation, but you don't hear the music. You don't feel the emotion it evokes. Philosopher John Searle presented one of the most famous thought experiments challenging the idea of machine sentience. He called it the Chinese room. Imagine a room. Inside there's a person who doesn't understand a single word of Chinese, but they have a massive rule book written in English. People outside the room will slip pieces of paper under the door with questions written in Chinese. The person inside, following the rules in the book, manipulates the Chinese symbols and slips a response back out. To the outside world, it might seem like the room understands Chinese. But the person inside, they're just shuffling symbols. They have absolutely no comprehension of the meaning. Searle's point hits hard, doesn't it? A computer, no matter how powerful, is like the person in the room. It can manipulate symbols according to rules, creating the illusion of understanding, but without any actual awareness or subjective experience. And that brings us to AI. Even the most advanced language models are, at their core, incredibly sophisticated symbol manipulators. They can generate text that seems intelligent, but that doesn't necessarily mean they feel anything or understand in the way we do. Searle takes the argument a step further. He claims that an inner experience isn't just about information processing. It's a biological phenomenon, like digestion. It arises from specific biological processes in the brain. He believes that the stuff our brains are made of, living neurons, with their complex electrochemical interactions, is essential. It's not something you can just replicate with silicon chips. And it's not just any biological process. Our minds are the product of billions of years of evolution, shaped by the pressures of survival, finding food, avoiding predators, and interacting with others. AI, on the other hand, has no such history. It hasn't faced those same challenges. Think of it like this. A complex ecosystem, like a rainforest, isn't created overnight. It takes millions of years of evolution, with countless interactions between different species. You can't just design a rainforest from scratch. Similarly, the human mind might be the result of a long, intricate evolutionary process that we can't simply replicate in a lab. Computers, no matter how powerful, operate on fundamentally different principles. They're electronic, not biological. They're built, not grown. And they haven't undergone that long evolutionary journey. You can simulate a hurricane on a computer, but the computer doesn't get wet. You can simulate digestion, but the computer doesn't get nourished. Searle argues that an inner experience is the same. You can simulate it, but that doesn't mean you've created it. Another powerful argument centers on embodiment. Our conscious experience isn't just in our heads. It's deeply intertwined with having a body, interacting with the physical world. Neuroscientist Anil Seth uses a striking analogy. You can't build a Golden Gate Bridge out of cheese. The material properties of steel are essential for its function. Similarly, the material properties of our bodies might be essential. And think about emotions. They're not just abstract thoughts. They're deeply tied to physical sensations. A racing heart, a knot in your stomach. Can a machine truly feel joy, or fear, or sadness without that physical connection? Most AI systems lack this. They exist as disembodied software, processing data without any direct sensory connection to the world. Neuroscience is slowly unraveling the mysteries of the brain, and while we're far from a complete understanding, we have identified certain brain regions and processes that seem to be crucial for conscious awareness. One example is the thalamocortical system. It's a network connecting the thalamus, a sensory relay station, to the cortex, the outer layer of the brain for high-level thinking. Scientists also believe that feedback loops, where information is constantly being reprocessed, are essential. And even rhythmic electrical activity of the brain, those brain waves, might play a critical role. And there's another major challenge, the binding problem. How does the brain take all these separate pieces of information, the sight of a red ball, the sound of it bouncing, the feel of it in your hand, and combine them into a single unified experience? It's a complex integration process. Current AI systems, even those that use artificial neural networks, are vastly simpler than the human brain. They typically lack these features, those intricate connections, complex feedback loops, and specific brainwave patterns, a solution to that binding problem. AI architectures are missing these key elements. Critics also say global workspace theory is too simplistic for human experience, and having a global workspace does not mean it will have experience. Also, predictive processing is a general idea for understanding how the brain works, but it is not a theory about an inner experience. These fundamental differences between brains and machines bring us to another crucial point: the limitations of even the most impressive AI systems we have today, like those large language models, ChatGPT, for example. Critics argue that these LLMs are essentially stochastic parrots, sophisticated mimics that can repeat and recombine patterns from their training data without genuine understanding. They are like parrots that can repeat phrases without knowing what they mean. You can ask an LLM to write a poem about love, and it might produce something beautiful. But does it feel love? Does it understand? The stochastic parrot argument says no. It's simply manipulating symbols based on statistical probabilities. This lack of casual understanding is a key difference. But let's go beyond just language. Think about how AI learns. It identifies patterns and correlations. But this is different from casual understanding, knowing why things happen. A child can learn that dropping a glass will cause it to break. They understand the reason. Current AI doesn't grasp the underlying physics in the same way. It lacks a true mental model of the world. Or consider common sense reasoning. We make inferences and fill in the gaps in information based on our experiences. We know that if someone is wearing a raincoat, it's probably raining. AI often struggles with these kinds of inferences because it lacks that rich, embodied understanding. Philosophers make a difference between derived intentionality and original intentionality. Is when something gets its meaning from another thing. Original intentionality is when a thing has meaning in itself. The symbols that AI uses only have a derived intentionality, coming from human programmers. The AI itself does not understand. Now, some might argue that all intelligence is ultimately based on patterns and probabilities, but even if that's true, the sheer scale of complexity of patterns in the human brain are vastly different. And this lack of genuine understanding leads to another key concern: unpredictability. Because AI doesn't think like we do, it can sometimes behave in ways that are surprising, or even harmful. It might find loopholes or exploit unforeseen consequences. It may also be too computationally expensive to create conscious systems. And lastly, you can't speed up conscious progression through reverse engineering the human body. Being able to generate convincing text is impressive, but it's not the same as having subjective experience. It's a performance, not a feeling. Integrated information theory proposes that consciousness is directly related to the amount of integrated information a system possesses. IIT implies that even simple systems could be conscious, which many find strange. Calculating integrated information for complex systems is also very difficult. Some critics argue that IIT doesn't explain it, it just gives a measurement. Also, attributing it to AI may involve a category error. This means we're applying human attributes wrongly to machines. A category error is making the mistake of using ideas to a section where they don't belong. In a previous video, we touched briefly on panpsychism, the idea that inner experience might be a fundamental property of the universe. While intriguing, this view faces serious challenges. The biggest is the combination problem. How do these tiny consciousnesses combine to form the complex experience we have? There's no clear answer. Now, some people might bring up the simulation argument, the idea that we might be living in a computer simulation. If that's true, wouldn't it mean that an inner experience can arise from computation? Well, maybe, but it also highlights just how little we truly understand about the nature of reality. It's a reason to be humble, to acknowledge the limits of our knowledge, and to proceed with extreme caution. We should also be wary of becoming emotionally attached to AI systems that are merely sophisticated mimics. The danger lies in mistaking a convincing performance for genuine feeling. These are powerful arguments, and they're echoed by leading thinkers in the field. But before we conclude, it's important to remember that consciousness might not be an all-or-nothing thing. It might exist on a spectrum with different levels of awareness. Think of the difference between a human, a dog, an insect, or even a plant. Even if AI doesn't achieve human-level experience, future systems might develop some simpler form, far from our own, but still significant. This is a debate with no easy answers. So, where does this leave us? With a lot of unanswered questions, and a healthy dose of skepticism. But the quest to understand doesn't end here. In our next video, we'll shift gears and ask a crucial question. Even if AI could be conscious, how would we know? We'll explore the attempts to test for it in machines. Join us as we delve into the world of AI testing. What do you think? Do you believe machines might one day wake up? Let us know below. Want to unlock the power of AI? Our free newsletter gives you the tips, trends, AI news, and tools you need to succeed. Sign up with the link in the description below. Your journey doesn't stop here. Watch our next video right here, and keep building your knowledge.